Okay, so we're going to do 5, 5, and 5, 6 multiplying polynomials. I'm going to add both of them together and do it as one lesson, and then in the next lesson I'll do dividing. So what you're going to do is, or learn in this lesson, is you're going to multiply a constant term into a polynomial. The next lesson will be taking a monomial and going into a polynomial, multiplying it in. And then we're going to do dividing as well. So you're going to do this both symbolically and pictorially. So doing the algebra and also by drawing a picture. So let's review first what multiplication means. So when you multiply, what it actually is, it's repeated addition. So 3 times 4 is the same thing as adding 3 4s together. So 4 plus 4 plus 4 is 12. That's just tedious to do. So another way we think about it is 3 groups of 4. So the way that we show the picture is by doing 3 groups of 4, and the area that it covers is actually the product. So since we have 12 tiles here, the answer will be 12. Another thing we have to review is how do we multiply and divide integers, and this is something you did in grade 8. When I multiply 2 positive numbers together, I end up with a positive. Same thing with 2 negative numbers. I'm going to end up with a positive product. If my signs are different, my product's going to be negative. Well, what does that look like in algebra tiles? Okay, so let me just get to the place I want to go to. Okay. So in this situation, I have positive 3 times positive 4. So I have 3 rows of 4 positives. So I have 3 rows of 4 positives, which is equal to 12. But what happens if I add a negative in there? Positive 2 times negative 3. These are 2 rows of 3 negatives. So therefore, I have 6 negative tiles total. If my first integer is negative, I'm actually going to take 4 positive integers, 3 groups of them, and then I'm going to flip them. And that's why I have 12 negative tiles. In negative 2 times negative 3, I have 3 negatives, which were red to start with. I have 2 rows of them that need to be flipped, and that's why I have positive 6. Okay, so that's just a neat little review of what you guys did in grade 8. So when we multiply a polynomial by a monomial, the monomial could be a constant term. It doesn't have to be, but just for today's video, we're going to keep it a constant term. Students are expected, like I said, to do this both symbolically using the algebra and pictorially. We're going to use algebra tiles first, and I'm going to introduce the area model. Before we can use the algebra tiles, really important that we cover the concept of what an x squared tile means. Well, this length right here is x. This length right here is x. And when we multiply them together, I get an area of x squared. And that's why it's called the x squared tile. This tile actually fits perfectly onto there. And that's why this length right here is x. This is actually 1 unit. We're going to call that a unit. So when I find the area, x times 1 is x, and that's why it's called the x tile. And you can see that these 2 lengths are equal. So I actually have a square that's 1 unit by 1 unit. My area here is 1, because 1 times 1 is 1, and that's why it's called the unit tile. So we're going to use both length and widths and area in order to help us with this concept. So here, please note for all examples in this lesson, we're just going to, instead of always having the legend, I'm just going to say that white is positive and black is negative, just to keep it simple. Make sure you always have to read your legend when you're doing the questions, though, on your quizzes and on your exams. So if I have a class example that asks you to simplify 3 times 2x using algebra tiles. Well, 3 times 2x just is repeated division or addition, 2x plus 2x plus 2x, or 3 groups of 2x. So if I want to show this pictorially, I'm going to put 3 of my unit tiles here and 2 of my x tiles here. And we're going to create our rectangle that fits these dimensions. So this dimension fits here and here. So that one goes there. The same thing here. I'm actually fitting dimensions. This dimension fits, that dimension fits, so that's the tile that fits in there. And I'm going to continue to do so until I get my rectangle. You need to make sure you have a rectangle. Okay? Now, like I said, the area is your product. So this right here is your product. Oh, how many do I have? I have 1, 2, 3, 4, 5, and 6. So I have 6 X tiles, so 6X. Let's go on to the next one. I'm just going to extend this a little bit. So now I have -2 times 4X. So I have 2 groups of 4X that are flipped. That's what it actually means. But let's see what that looks like pictorially. So I have -2. And I have 4X tiles. And we're going to multiply these together. So I have 2 groups of 4X, but I'm going to flip them. Okay? So if I flip a white, I'm going to get a black. If I flip a white, I'm going to get a black. And I'm going to continue to fill in the shapes that fit the dimensions until I get my rectangle. Okay? The area is my product, and I have -8 x's. So my product is -8x. Let's go on to the next one. So I have -3. So the number one question I get is, do my -3s always, or my units have to be along this side? Can they be up here? And the answer is yes. So I'm going to show you how to do this, except the only thing is that I'm going to have to flip these. Oops, I picked the wrong tile. I'm going to have to flip these, so it's going to take me a little bit of time. But you'll see you'll get the exact same rectangle. Okay? Okay, let me just move this down so that this will fit. Okay, so you'll see it'll be the exact same thing. Just your rectangle is going to be height-wise as opposed to long-wise. Just, I don't even know if that's a word, but that you know what I mean. So what I'm going to do is I'm just going to choose my 9 just to make it a little bit easier. I have to like kind of rotate these around. 1, 2, 3, 4, 5, 6, 7, 8, and then 9. And I'm just going to rotate these now so that they'll be easier just instead of doing them one by one. Okay, so now I have 3 black tiles. I have 3 groups of them and I have to flip them. Okay, so that's why it turns white. I have a black tile. I have this and I need to flip it. Okay, because that's what these black tell you to do. The negative tells you to flip. So now we just fill in our area of our rectangle. Okay, so we still get positive 9x. Doesn't matter if you put your units on the top or along the side. You're still going to get the same area of the rectangle of positive 9x. I mean, that's the exact same one. Obviously, I put that one in there. So now, when we multiply a constant into a monomial, all we do is multiply the constant term by the numerical, let me spell that correctly, numerical coefficient of the monomial. And I'll give you guys some time just to write that. I'm just going to do this. This is everything that you need to write. Okay. You're gonna, oh, I noticed I spelled multiply wrong. Let's just go and change that too. Okay, So all we did, if you notice, all we did was we multiplied the numerical coefficient by the constant term. That's it. Didn't really change the shape of it. So let's try multiplying a constant into a binomial. And we're going to show this using algebra tiles. So if you haven't quite finished writing this down, just press pause and then come back. Okay, so this looks a little bit different than what you have in your workbook, but that's okay. You'll get the gist of it. Now remember at the beginning of the lesson I said you're going to use the rectangle method. So this is the rectangle method down here, and I'm going to show you how to use that right after I do the algebra tiles. So notice I have a constant term, and notice I'm multiplying it into a binomial. The same rules apply. So I have 3 positives, and I have 2 x's and 2 units. Okay, now I have to create my rectangle that's going to fit in with these shapes. So this dimension fits that one, this dimension fits this one, so that one goes there. Okay, same thing. Dimension, dimension, we know that one fits there. So these are all X tiles in here. I don't have to show you with every single one. There we go. Now we have to fill in this one. So here, this dimension fits here, that dimension fits here, so this one goes right there. And the same thing, that dimension, that one goes there, and you get the hint. We can fill in the rest. Now I said the product is actually the area of the rectangle that was created. So here's my rectangle. So the area of that rectangle is 6 x's. I have 6 x tiles, 1, 2, 3, 4, 5, and 6. And I have 6 units, so 6x plus 6. In the rectangle model, what you do is you find the area of each of the rectangles. So what you do is you split up your binomial into 2 different rectangles. 3 times 2x is 6x. And 3 times 2, because this is the same length, right? This is the same length here. 3 times 2 is 6, positive. And I'm just going to erase the 3. And there's your polynomial, the exact same thing. So that's all you do in the rectangle method, is you just take your polynomial or your binomial and put it into 2 rectangles and find the area of each of your rectangles. Okay, so let's try this one. So this is what your workbook looks like now. So I have 2 negatives, so I'm going to just stay black here. And I'm going to try and draw this to the best of my ability, because you guys had to draw. So I have 2 negatives, so I have 2 black ones. I have 1 X tile, and then I have 4 unit tiles. So now what this says is I'm going to have 2 groups of these tiles, but they're flipped. So it was white, and now it turns black. It was white, and now it turns black. I need to flip each of these tiles. It was white, it needs to turn black, and so on and so on. So actually I have all black tiles here. Once again, my area is my product. I have negative 2x tiles, and I have negative 8 unit tiles. If I use the rectangle method, I take my binomial, I separate them by 2 separate by 2 separate rectangles, and I find the area of each rectangle. So negative 2x, this is my negative 8, so if I put them together, I get 2x minus 8. Okay, let's try one more. Here I have simplified negative, open bracket, 2x minus 5. Remember, I said if you don't see a number, you assume it to be 1. So this is another way of saying that is negative 1, 2x minus 5. So I have -1 on this side, which is a black tile. I have 2 2 X tiles, and then 5 negative. I'll color them in right away because they are black. Okay, so they're black, so I'm just going to color them in black. Okay, so now this says I have one group, and I'm going to flip these tiles up here. So it was white, it becomes black, and that's the tile that fits that dimension. It was white, it becomes black. It was black, it becomes white, and white, and white, and so on. So my answer is my area of my rectangle. This is my area right here. That's my product. So -2 x's plus 5. And geez, if I was to put, remember if I was to put like a polynomial in front of this and I subtract, what did I do? I switched the signs and look what happens here. So this is, you've seen this before in lesson 4. So in the rectangle model, again, I take my binomial, I separate them into 2 separate rectangles. I find the area of each of my rectangles. -1 times -5 is +5, and I get the exact same thing. So if I actually look at taking a constant term and multiplying it to a binomial, we actually call that the distributive property. So I'm just going to write down, and I'm going to not tab it, I'm going to capitalize it. Distributive property. Now, no matter what math class you take in high school, you will hear this. So the higher level math courses or the lower level math courses, you will deal with distributive property. If you Google distributive property, you're going to see the following. A, open bracket, B plus C is equal to, and they actually draw the arrows, A times B and A times C. You have to multiply each term by the constant that's outside. So algebra tiles will only take us so far. We don't have a tile that represents every single type of polynomial. So we have to use the symbols or symbolically in order to do those higher level questions. Not higher level, just those tougher questions that we don't have tiles for. So we're going to use the distributive property in order to solve for these. So if I multiply this in, I'm going to get -6m. And if I multiply that in, I'm going to get +12. Distributive property tells me I multiply the monomial, or sorry, the constant term into my first term, which is -4x. And my second term, which is -8. Now I have a trinomial. It doesn't matter how many terms I have in my brackets. If it's all in the brackets, that means I have 4 groups of them. So I have to multiply this number 4 into each of my terms because I have 4 groups of them. So I have 4 of my x squareds. I have 12 of my x tiles that are black because it started off black. And then I have 20 of my unit tiles because I had 5 and I have 4 groups of them. So I have to distribute that number, that constant term, into each of my terms in the brackets. Okay, and the same thing. If there's a term that's not in the brackets, don't multiply it. It only goes, this number tells you how many of these, how many groups of these that we have. Now the number one mistake is forgetting to multiply the negative into each of the terms. So make sure that you watch your signs. So -2 times -n squared is +2n squared. I have 2 groups of them, and they were black, but I need to flip them. -2 times +2n, whoops, is -2, -4n. I have two groups of white tiles that are flipped. And -2 and -1 is +2. I have a black tile because of the -1. I have two groups of them and I'm flipping them, so +2. In this example, it's just a little bit tougher of a trinomial inside the brackets. So I'm just going to multiply that -5 in. I'm going to get +10 x squared, +15 xy, and -5 y squared. Don't be scared to draw these arrows. It's expected of you. Okay? It's very expected even on a diploma for me or for anyone to see these arrows. So draw the arrows in. Okay, so let's do some quick checks here. So if you guys want to pause this video and work on them and then come back to these and see if you did them right, that would be great. If not, just continue to play the video. So welcome back. So here are the answers for your quick check. 4 times 5, I have 4 groups of 5 x's, so I have 20 x's. I have 3 groups of +5n that need to be flipped because of the negative, so I got -15n's. I have 2 groups of each of these terms, so that means I have to distribute it in. So I get 6x minus 2. I have a trinomial now. I have 2 groups of each of these terms, so I have to multiply that 2 in. So I have 2m squared plus 2m plus 3. Now I have 3 groups of these terms here, and then I have to flip them. Okay? So I have to distribute that 3 in and then flip the tiles. So it was positive, it becomes negative, and I have 3 groups of them. It was negative, it becomes positive, and I have 3 groups of them. It was positive, you flip it, you get negative, and you have 3 groups of them. And same thing here. I have 2 groups of each of these terms, and then I have to flip them. Okay, so let's draw in our arrows. That's very normal to have those arrows drawn in. So -2 times 4 is -8x. -2 times +3 is -6y. And -2 times -2 is +4. So hopefully you got all these correct. So what I want you to do now is practice what we've learned. 9a, 11a, 11c, 12, 15, 17, and 22, and make sure you check your answers on page 506 to 511.